My name is Ben Ellert, and I'm a research scientist in biogeochemistry, soil science, essentially with Agriculture and Agri-Food Canada just up the road. So Farming Smarter is our neighbors, and we really like to work with them, and it gives us an opportunity to get out and mix with folks like you. This particular study, we've got some research funding from Alberta Wheat and Barley and Ardar and others. We're looking at a crop residue experiment. Okay, we call it our dryland crop residue study, and it's been ongoing for over 15 years at Agriculture and Agri-Food Canada. It's a very simple, large plot study, and there's lots of interest in soil carbon management, soil carbon sequestration, and it all comes down to crop residues. It's kind of the age-old, boring kind of study, but what we got funding to do is for a long-term system, just looking at what crop residue management looks like. So I've got a little bit of a review of some of the things that influence crop residues, and mainly I'm focusing on a dryland cropping scenario. This is an irrigated cropping system. It looks much better than our actual plots, our experiment. But what we've done in this study is we have, it's continuous wheat essentially, and we have manipulated crop residue inputs. So we've got 3 levels of inputs. We've got the sort of the normal situation where the grain is harvested and all the residues out at the back of the combine are deposited on the field. And we've got another system where residues are removed and exported from the system. So that's to simulate something along the lines of a biofuel or a bioproducts kind of thing, where you're harvesting those residues. The only thing that remains behind is the standing stubble below the cutter bar height. And then the third system, and the agronomists just hate me for this one, is a supplemented residue treatment, where we're doubling up the residues. And that's the thing, we've heard a lot about carbon management, and we're going to put a cover crop in, and we're going to sequester carbon. Well, this is something where we're really manipulating the carbon inputs to the system, and we want to look at the influence of that on soil carbon storage, but also soil health and the performance of our agro-ecosystem. So that gives you sort of an overview of the study. And as just kind of a review, I've summarized essentially the main things that influence the balance between your soil carbon stocks is essentially the balance between photosynthesis. Photosynthesis is a lovely thing. It draws carbon dioxide out of the atmosphere and accumulates in plants, and we use some of that material. That's what feeds us. And the other side of that equation that too often is neglected or ignored is the decomposition side of it, okay? What's the fate of those residues? So a number of things that influence the inputs is the crop type. Big factor there, of course, is whether it's an annual crop or a perennial cropping system, especially the roots, okay? And there's lots of different approaches and strategies. Integrated crop livestock systems where you have a perennial forage for a few years. You're putting lots of carbon into it. Or also there's interest in having perennial crops where we also harvest the seeds. So that's something that's a factor. The other thing is we're talking about photosynthesis, and that's essentially producers and agronomists who are in charge of managing the carbon cycle. That's what we're doing. We're managing carbon. And crop yield is very important because that's the diversion of carbon from the atmosphere to something we can harvest, get some income out of, and maybe even eat, or at least feed to a cow. The other thing I'm going to talk a little bit about is plant partitioning, where the carbon goes once it's taken up by photosynthesis. And the other thing, of course, that influences the input side of the equation is the importation of carbon to the system. People talk about livestock manure, and it's a wonderful thing, but often it confuses your view of the carbon cycle because it is an importation. You go to a feedlot in southern Alberta and you see super bean trailers coming in with barley grown in Saskatchewan. We're importing photosynthate from Saskatchewan when we do that. And it does, of course, when you put that silage or barley grain through a feedlot and then take the manure tends to be dumped really close to where the feedlot is, and that is an import of carbon to the system. On the decomposition side, there's lots of things that influences the rate at which those residues are decomposed back to CO2 released to the atmosphere. Big one is the soil climate, the agroclimate. Depends a lot on temperature and moisture. Big difference between an irrigated cropping system versus a dry land cropping system. Aridity also slows down decomposition, and that's a big factor in zero tillage. When you are no longer mixing those above ground residues into the soil, those residues, especially in our country where we have high rates of evaporation, those residues stay high and dry and they decompose more slowly. So that's another factor. I guess it could be viewed as residue placement side of it. The other thing that influences it, aridity has it's a major factor in decomposition. Another thing some of you may be using, how many of you are using stripper headers? Okay, that's another thing that I'm really interested in. And there was a lot of interest when we had the transition from systems that had quite a higher frequency of tillage versus systems where we didn't till as much. And one of the things that we see is when you go to a stripper header, those residues are even further off the soil, so they stay high and dry, and decomposition is slowed. Another factor that definitely influences that is the photodegradation, exposure to the sunlight, both the visible as well as the UVA and UVB part of the spectrum. They fill in for, when you put it in the soil, you have microbial exoenzymes that chop up those residues and decompose it. When it's high and dry and exposed to the sunlight, it's that radiation that does the same thing. So there's compensation. You have more photodegradation in a system with a stripper header. The other thing that we're going to talk about here a little bit more is residue harvest, whether you remove those residues for various reasons. And another thing there's lots of interest in, you might hear something about it, is the residue chemistry. And here I'm talking about the organic structural chemistry of crop residues. The most abundant polymer on Earth is cellulose, and the most abundant phenolic polymer on Earth is lignin. And you hear how relatively hard and persistent those things are. And especially the people making biofuels, they do a lot of work on figuring out how to break those things up so they can convert them into biofuels and bioproducts. Our soil microbial community has no problem with that whatsoever. So there are, for various reasons, there's modified corn where they've decreased the lignin content with the brown midrib trait. There's less lignin in that corn. It doesn't make any difference from the decomposition side. The soil microbial community can handle that. So hopefully that isn't too elementary for you. I got another page I wanted to talk a little bit about. Maybe I could get somebody to hold this for me. Jeremy's going to turn to the next page. The other thing I wanted to talk a little bit about is the partitioning of the photosynthate once it gets to the plant. Agronomists, we tend to focus on the blue part, that's the top part, and that is what's in the harvested product. That's the grain carbon, okay? Well, dry matter on this side, carbon on that side. So that's the blue part. The green part is the above ground residues, that's the non-grain shoots, and the red part is the roots. Roots is relatively small, controversial, very difficult to measure. A lot of people talk about liquid carbon and stuff like that. This, we do our best to measure that. And a lot of times it's easier, we estimate the roots from the above ground component, but that shows you your total carbon that you're managing. And of course, the actual amount of carbon input depends on your yield. So you might not be able to see these numbers. I hope Jeremy's sharing the other document over there. This is a 40 bushel acre canola crop, 35 bushels of peas, 55 of wheat, and 75 bushels acre barley. So you have different carbon residue inputs. The other thing is the technology, especially plant genetics, influences the partitioning of carbon between the shoots and the harvestable part. Can you go to the next paper in there, Jamie? I'm sorry. This probably. I think it's got a picture. Yeah, that's the one. And maybe that's moot. That's the next one. I've just got a couple of pictures showing. I did put it in plastic because I thought it would rain. I should have put each one in individual. All this shows is what our plant breeders have done is they've shuffled plant carbon. This is the old Marquis variety. I put this in beside our building for our summer students. This tall statured wheat is Marquis, and this is AAC Brandon. So what that's done is you shuffle more of your carbon to the harvested part. Our plant breeders have been more successful at reshuffling carbon than they have at increasing net photosynthesis. Sorry to say. And that influences how we're managing carbon. The other thing, the bottom part there shows the harvest method. And this is in the old days. Our research center goes back to 1906. And when we look at our early studies that go back to 1910, we have to keep in mind that it was a stationary threshing machine. So everything above cutter bar height was removed. So that's a system where we're harvesting residues. Next chart, I've got another chart in here, and I don't know, maybe Marcy will take issue with this one. It's another partitioning one. That one, yes. So this is the same chart I showed before, partitioning the carbon amongst the different components, but rather than the crop plant, this is the entire agro-ecosystem. I'm sure none of you have weeds, or could that be a cover crop? But I've actually increased my net primary production. My amount of dry matter that I'm producing and the amount of carbon that I'm pulling out of the atmosphere, I've increased that. Unfortunately, my money part of the crop, the grain, has shrunk. And I've got weeds. So weeds are residues that you're producing. You can, if you want to increase crop residues, you can grow more weeds. I wouldn't necessarily recommend that. But that's what we're doing, okay? In agriculture, the breeders, they talk about plant carbon partitioning, and they're just looking at the crop part. But when we're managing the agro-ecosystem, we have to take consideration of everything. How much photosynthate is being allocated to weeds? How much is being diverted to insect pests or disease organisms and that sort of thing? And yeah, so the other thing, let's see, oh, the next one is just a map of the study, and we're probably best to walk through that. Yeah, this is even the right way. This shows the different treatments that we're standing in front of here to demonstrate. And this is sort of mimics our long-term study that we have over at the research center. Over there, the bare one, it's the one that's going to be most visible. That is a, oh, I do have it reversed because I was going to talk from the other way. That's okay. Yeah, upside down. That's the chem fallow one. And then we have the supplemented residues are the first two ones. You should see heavier residues between the crop rows, and then it's the residues retained. These should be the residue removed ones. You should see precious little residues between there. The other thing, of course, that has a big influence on your crop residue inputs and carbon cycling is your yield. And in agronomy, the big nutrient element that we're looking at is nitrogen. So there's a nitrogen treatment here. One is nitrogen fertilized, one is not. There's lots of talk about nitrogen fueling decomposition and burning up all of your carbon inputs that's going into the soil. Don't worry about that. All of our research in Western Canada, at least, is showing that when you fertilize with nitrogen, you grow a bigger crop, you get a better yield, you make more efficient use of the water that's there, and you're putting on more residues. And we are actually measuring, because it is a long-term study, we are measuring the increase in soil carbon sequestration. And that is relatively tricky business. We've got 6 replicates over there, large plot study, so we can do that kind of work. The big sort of take-home message on that is the soil microbiome. We've done a number of work on a number of different facets looking at processing of those crop residues by the detrital food web. The system is remarkably resilient to that residue loading. Actually, with heavy residue inputs, it can present mechanical issues at seeding time, so you can get impaired seedbed establishment. That's very dependent on ag engineering and the seeding machinery that you're using, but that's one potential drawback. And like we heard previously, you know, the temperature influence is influenced by the residue loading. Some years we even get a little bit better yields from the residue removed treatment, but the yields aren't really hugely different. We do have huge difference in residue inputs. We get a big yield response to nitrogen, just with nitrogen and without, and our residue manipulation has a huge effect on carbon inputs as well. Over the scale of about 20 years of that difference in residue input, you're seeing less than 5% accumulating in the soil. So the take-home message is all of these things that you can do. You can grow a cover crop, which is a very relatively small manipulation of the carbon cycle relative to this extreme manipulation, which really, it probably isn't practical or agronomically relevant. Certainly that supplemental treatment, that is not a recommended practice. But that is for us to better understand nutrient cycling processes in these studies and to calibrate our models that we're using to hold up against reality as to how the ecosystem is working and how carbon and nitrogen cycling as well. I'm not going to talk about nitrogen cycling today so much, but the residue loading also influences the nitrogen cycle. It depends on which part of the crop that you're harvesting. There's a difference. Your C/N ratio in the straw part is very wide relative to the chaff. Does anybody here harvest chaff? Does anybody use chaff bunchers, or is that a 1980s technology? The chaff has a little bit of a narrower C/N ratio, and apparently if you feed it to a ruminant, you can get some feed value out of the chaff. So back in the day when there was more mixed farming systems, that was something we saw. So with that, maybe we can just walk through the plots and have a look, and if there's any questions, I'll try to answer them, but maybe I'll start from this end, and I'll take my key from Jamie so I might know what I'm talking about. Yeah, here you can see, I think you can see the response to to nitrogen, if I've got this right. This is supposed to be the residue removed treatment, I believe. Are those the same? There's residues there. Okay, that makes sense. Okay, so this is not the residue removed. This is the nitrogen. You can see the yellow response. Yeah, this is the residue removed. So it's hard to see here. So there's lots of concern in cereal cropping system, especially when it's cropped continuously. There's less of a concern about soil erosion because we have anchored stubble there every year, even where we're exporting the residues. A lot of agronomists, they rail against the concept of harvesting residues and exporting those from the system. Yes, we can measure the decrease in soil organic carbon when you do that. Whether that has any influence on the functioning of the system, I certainly can't say after 15 years of studies. So it's not really detrimental. So I wouldn't say no, absolutely not. It probably doesn't make a lot of sense in this part of the world where our yields are lower.
So if I'm a farmer pulling off all my straw and sucking it away, I should feel no guilt.
Provided you're managing the other part correctly. You know, you got to look at the nutrients that you're moving off. But in this area, I mean, we're lower yield, so the amount of material that you're moving off, I think you can compensate for residue removal, providing that you have sufficient anchored stubble to protect against erosion.
But the economic value of the straw in the nutrient standpoint is much more than you get for the straw.
Well, I work with farmers that I say that exact thing to them, and they go, well, it's easier for me to pay someone to come get it than to have to deal with all of that straw, so yeah, I'm taking a sacrifice.
And it's cash flow.
I guess my other question to that is, I mean, there's a lot of new companies that are coming up and asking for farmers' straw, and asking, you know, if they want to buy the straw to seek those opportunities, or is that something that we should maybe kind of look at very cautiously?
I would certainly look at that cautiously, and you look at the history of these straw processing facilities on the prairies, and that you gotta be you have to have a fairly high comfort level with risk to invest in those kinds of businesses. There's lots of competition in that whole fiber market between forestry and cereal crops, so that there's competition between the two, and they've actually changed over where it was built as a straw plant, and this is more closer to the forested region of the province where the moisture levels are higher, you're on a black soil, so you are producing more straw. So you can have an influence there. If you're in a mixed farming system and you have livestock in your system and you have opportunities to recycle that straw through a livestock production system, whether it's bedding or as a roughage to bulk up your feeding rations, and then the manure is returned back on, I think that's a really good opportunity for circularity in nutrient cycling. This study shows that the residue harvesting isn't as detrimental as what you might expect, but I don't think anybody's going to get really wealthy off it. And a lot of it depends on the crop. When you look at a cereal crop versus a canola crop, I've been trying to get the canola people to think a little bit more about the fate of those residues after you harvest these what can be fairly large canola crops these days. And a lot of that is because not just the carbon partitioning in that crop, but also the nitrogen partitioning. In canola, unlike wheat, in wheat we're harvesting protein. It's a nitrogen-rich thing. In canola we're harvesting lipid. Lipids are devoid of nitrogen. We harvest that and all of those pods go back onto the soil and there's lots of nitrogen there. And I think in systems with canola, we've got to be paying better attention at managing that part of the crop, so we're using those nutrients to advantage and not letting them bleed off into the environment as leach nitrate or nitrous oxide and those kinds of things. So those are an example of some of the considerations when you're managing crop residues or carbon on your farm. I've got ideas, I've got research proposals, I have nothing funded on that yet, but I think just the main thing, and that's a big part of nitrogen management, I don't know how much we're getting into that today, is synchronizing the nitrogen availability with the crop end demand. So if you can follow your heavy canola crop with a cereal crop with a high demand that's going to use that nitrogen, or maybe even better, a fall seeded cereal, maybe that's one way to take better advantage of that. But I don't have any research on that.
I'm wondering if you could discuss a little bit about these soil health indicators as they pertain to soil carbon. I know there's a lot of work being done in trying to help all farmers sequester more carbon. I don't know how accurate these measurements are. I think we love to have a measuring stick. I'm a little bit worried about how we brag about organic matter, for example. So we, as a farmer, oh yeah, I rose my organic matter from 2% to 3 or 4% by these farming practices, and it almost gives, I'm worried, a little bit of an inflated measuring stick, because I think a big part of it is that they're not tilling as much anymore as well. So I'm wondering what your thoughts are on that.
Yeah, no, I think that's a good question. A lot of my work has been on trying to quantify the stocks of carbon in the soil, and that's tough. It's a slippery thing to do a good job of measuring the stock of carbon that's there. And even more difficult than that is to measure so-called carbon sequestration. What is carbon sequestration? It is a change in the stock of carbon. So we want to take our stock from here to here. We want to increase soil carbon. And there's lots of expectations on agriculture to solve our problem. Agriculture industry is far from being carbon neutral. We do not have a whole lot of potential for sequestering carbon to sell to other industries. And if you think you're going to offset your jet trip to Mexico by sequestering carbon, I've got some lakefront property in Florida for you. I mean, it's not gonna happen. So that's the thing. The other thing, when we talk to farmers, I don't even like to call it organic matter. I mean, it is organic matter. The herbicide, the labels on the herbicide still say, well, you can't use this herbicide if your organic matter is this or that. The fact of the matter is we cannot measure organic matter. What we measure is organic carbon. If your standard soil test, the measurement of organic matter on your standard soil test is not up to the task of measuring the stock of carbon that's on your land. I hate to say it to you. And it certainly is not up to the task of telling you whether you're sequestering carbon or not. Most of those labs do not even have the instrument required to measure carbon. And when we analyze the soil, we are measuring carbon, not organic matter. So that's sort of the carbon stock thing. The other part of Ken's very good question was these indices of soil health. And there's lots of things that they're using, and they're looking, not all soil carbon is created equally, okay? And we've got studies using radiocarbons. And this area in particular, the mean radiocarbon age is on the order of 1,400 years. That is old. Some of the carbon in our soil is pre-glaciation. It is dead. All the radiocarbon is decomposed of it. Some of it was deposited yesterday by photosynthesis, roots slewing in the ground. Some of it was deposited in the 60s, and we use that pulse of bomb carbon that was released from atmospheric nuclear testing. So we've got a feel for the different components of carbon in these. Most of the soil health indices are looking for the very recently deposited soil carbon, and that's one of the things that this residue study is showing us. As good as any soil health industry is coming out here and picking a 1/4 square meter of residues off, because that's labile carbon. Some of the indices that they use are things like a burst test for CO2. That's one popular one. And it's that's a good way. A lot of these incubations, I like a little bit longer incubation than that. And essentially it's a bioassay in the laboratory. There's no plants growing, and you let the microbial community decompose what's there. So that's one indice of labile carbon. Another thing you can do is, instead of microbial processes do it, you can use chemicals. Permanganate oxidizable carbon is another popular indice. Depending on which battery of soil health tests you use, there's a number of them, and they will give you an indication of the rapidly cycling carbon pool in your soil. Whether that means it's healthy or not, I don't know. And a lot of times I find it a little bit conflicting, because they're measuring these tests, and if you have a high burst test and lots of CO2 production, that means it's a healthy soil. Well, that's true, but if you've got that much CO2 coming off, that also means you have lots of decomposition. It's not necessarily very good for carbon sequestration. And carbon sequestration, you might not get so infatuated with that, because a lot of the function, that rapidly cycling organic matter is really good. It's a buffer to hold on to our nutrients and hopefully release them in sync with demand for our new crop. So that's why an understanding of this is better than actually farming on the basis of a number. And there's been lots of debates amongst us in soil science as to whether it's even possible to assign a number to soil health. People want to use multivariate statistical methods, and it's a little bit like cover cropping mixtures. If one species is good, 3 species is better, and 30 species is way better. And that's sort of like the soil health indices. One measurement is maybe not so good, but 3 is great. And if you can do 30, that's got even better. I don't know if I buy that either.
Do you think it's better to maybe stick with say indicators like soil aggregate stability instead of trying to measure active carbon or even carbon sequestration or even organic matter? Like you said, it's really hard to estimate it for the annual crop production as far as farmers are concerned.
As far as farmers are concerned, my favorite estimate is above ground net primary production and the partitioning of your components. If you've got a system that's got a weed in it, it's kind of handy to know how much is crop biomass and how much is weed biomass. If you've got a system with cover crops in it, it's kind of nice to know how much trade-off, if any, is there between crop production and cover crop production, or is your cover crop production actually bolstering you? And when you have legume cover crops are a wonderful thing. We need, for environmental performance, we need that biologically fixed nitrogen in our system. But we need measurements on that. So as a soil scientist, I hate to say this, but I think it's plant biomass is that's your starting point. In terms of erodibility and that kind of thing, the aggregation methods aren't bad. It depends on how much work it is. Some of the soil physical measurements, you take a soil sample and you dry it and you crush it and then you sieve aggregates out. I don't know the relevance to that. Some of the soil health indices, they've got cell phone apps and things like that to measure aggregate slaking. And that is something that's really practical. I don't know a lot about that, but I think that's something that's potentially useful. One of the things, I guess a question before I'm asked the question, does anybody use the cell phone apps to measure surface residue coverage or even cover crop like Canopio and those kinds of things? Anybody use those kinds of tools? Farming Smarter does. Yeah, Farming Smarter does. So that's why I need to, that's why I benefit from interacting with these guys. I got to learn from them. Yeah.
You said that a really good indicator of that soil health is just the above ground biomass and productivity. Within our fields, there's a lot of variability, and I guess, you know, producers always want to increase that. We know we can mine our soils, we know we can be detrimental in terms of, you know, our farming practices. And so, like the soil health side, I feel like people are just trying to find a way to improve their soils and improve that productivity. So how does the carbon side relate to that? Is there like, I guess that's not what Ken was asking. Is there ways that we can see, you know, is that actually improving, and are these practices improving that areas, or is it just not? Is some areas just kind of doomed to be forever low producing just because of their, you know, soil analysis?
Well, one of the big issues, and that's why we heard Gerber talking about it first thing this morning, and we live in this area, so we get the phone calls from the media. The first thing you know, the circles of potato soil is up in the air, and we look across the river at the reserve and in February, and we see this stuff. So if you're letting your soil erode, that is not a good thing for environmental performance. From the standpoint of carbon sequestration, you know, putting my biogeochemistry hat, looking at the geochemical cycles, erosion, it's a tough thing, because when you take the standpoint of what the atmosphere sees, erosion isn't necessarily a bad thing. But for agricultural production and the sustainability of our industry, we cannot let our soil erode. So, you know, and that's the other question, the variability I think you were asking about, and how to make that more uniform. Keep your soil covered and keep the nutrient cycling. We need residues in there, but some of crop residues are, in some ways, they're most beneficial when they decompose. And in an irrigated cropping system, actually it's surprising now. If you came out here 2 weeks ago, you could see these differences in residues along these plots very much more clearly than what you're seeing today. Because in irrigated systems, decomposition happens. But even in dryland cropping systems, yes, we transition the system over to zero tillage. We build up a little bit of a thatch layer, but what we do is we create an environment, we retain a little bit of water, and there's checks and balances. The amount of carbon sequestration that you can achieve is finite. And that's one of the things that I've been feeding into the policy branch, and they don't like to see it. They want me to tell them how much carbon they're going to sequester. I said, well, here is my rate, but that rate is only going to persist for 40 years. And then you're done. You're back to zero again because you've re-equilibrated. Nobody considers the duration that it's feasible to maintain that carbon sequestration. So we need transformative change if we're going to address the climate issue.
Do we have time for another question?
We surprisingly have a lot of time. Although it's getting cold. So.
I guess, kind of jumping off that topic of knowing that there's challenging areas in a field that, okay, it'd be nice to bring this up to the other parts of the field that are performing well. It's not providing an economic return in this area, and from what I understand, there isn't really good, strong soil indices for me to track to see that change or to work on that change. So it sounds like it's more of conserving what's there than being able to measure growth by certain practices. So covering the loss is beneficial, but if you're spending money on covering soil loss in an area that already isn't providing an economic benefit, are you putting money in a place where it's not actually providing any return because there's no indices to determine if there is a growth of betterment in that soil to then provide a yield benefit to make the economics of that field more beneficial?
Welcome to the government grants we're currently faced with.
That's a clarifying question of me trying to understand this line of thinking.
Yeah, and that's the thing about the short versus long term. Another good question that Ken asked earlier, can we adapt this? And when do we know when to change and throw up our hands in despair and say, well, that didn't work, let's try something else? And it's how often. I think we need to be adaptive, but I don't think we should be adapting within the tenure of a PhD student, hopefully. Unless he's a really long PhD. and the reason I say that is some of these things are very difficult to detect. We look at, and maybe I'm going to contradict myself, some of the long-term studies, we had sweet clover in these studies. And the sweet clover was just hammering our yields in those things, and it was not performing. And it was there for probably too long because we didn't adapt frequently enough. But then we take that and we put it in a uniform cropping systems. Lo and behold, all those plots that had sweet clover in them performed dismally. Those are the ones that outperformed everything else, probably because we had built up a labile pool that had a fairly bit of nitrogen in there from nitrogen fixation by the sweet clover, and we were reaping the benefits of that. So these kinds of studies, they don't always turn up in a 3-year funding cycle. That's the problem.
And so I think your study is continuous.
Yes.
As I recall. I think you might have mentioned that, and so that, again, in terms of sort of residue removal, just because people going away, I mean, obviously, just our ability to grow close crops, crop cycling, sort of that residue that we keep with the cereal just means so much in terms of cover through that cycle. And that's kind of within the context of rotation, a lot of times.
Exactly. Yeah, you have something low, lentils, or they're probably prone to erosion even with residue retention. And although your residues decompose remarkably fast, like these are residue treatments, you come here in a month and without the signs and the plot plan, you're going to be hard to tell where are supplemental residues here and where they are not. But in that situation, under dry land, you have a lentil or a pulse crop on top of something where you've harvested those residues from a dryland system, not a good idea. That's an excellent point, Rob, for sure. You know, and that's, you know, that there's been analyses of that with increasing diversification, even in dryland cropping systems on the prairies. We run the risk of more susceptibility to erosion because of that lack of coverage and that greater diversity of crops. So that's
Driving across the landscape right now, you sure see that, you know, the horrible drought that we're facing through this spring, and you're thinking, wow, this land, you know, the knolls that have cover on them, you're thinking, how long is that going to have to go now, you know, to get through next winter, and you know, you can sure see where there's been better residue and stubble retention and things.
Yeah.
We've got a horrible year ahead of us here, I think, in terms of
resilient cropping systems, but even so, in this area, you know, where the noble blade was invented and things like that, under our dryland cropping systems, they're the ones where you tend to see the least erosion. It's dry beans, silage corn, and especially those two crops that we got to dig out of the ground in September and October, potatoes and beets. Those are the ones that are susceptible to erosion here. But that's, and the other place is some of our saline sloughs, where we see they're devoid of vegetation to begin with, and in the droughts they dry off, and then you get calcium sulfate. Nobody really wants a lot of that, I don't think. So that's another issue. And then the other big thing that can happen in our cherished zero-till systems with a heavy litter mat is wildfire. And when you have wildfire come across, then we're into urgent control measures to retain that soil. So to protect our soil against those erosive forces in these different sort of increasingly challenging times, residues is one tool in the box. The other tool is cloddiness of soil. And in annually cropped systems, we've got to use both of those. And, you know, multi-year drought, heaven forbid, that's a challenge for sure. And we can't be surprised if we have to confront those the way things are going.
All good? Join me in thanking Ben. It's always great to have a practical scientist